welcome back. Sorry this took a while going through these questions, the problem set that I had asked you to do. But let's take this opportunity and look at the questions quickly. All right. So these were problems on the implied domain of logarithmic functions. The first question that I asked you to try was number 1 here. Given that f of x is 2 log to base 3 of x plus 1 minus 5, find the domain and range of the function, expressing your answer in set builder notation. Okay, and the second part, which is in orange, because it requires you to know a bit about transformation of function, is to describe fully the transformation that maps the graph of y is log to base 3 of x onto the graph of f of x, which means onto this graph here, right? So let's just look at this quickly. Find the domain and range of the function, expressing your answer in set builder notation. And to do this, as before and very quickly, we use our understanding that for logarithmic functions, the argument must be greater than 0. So the argument, which is x plus 1 there, needs to be greater than 0. Okay, so in this case, x must be greater than -1, and this should be quite easy. All right, so the domain must be all real numbers, provided that they are greater than -1. Okay, we can sketch the graph of this function very quickly. X-axis, y-axis. X must be greater than -1, which means -1, the line x is -1 is a vertical asymptote. So we draw a vertical asymptote, that dotted line there, where that point where it crosses the x-axis being -1. Okay, we can find where the graph crosses the x-axis. Where does the graph cross the x-axis? The graph crosses the x-axis when y is 0. So if y is 0, then we have here 0 equals 2 log to base 3 of x plus 1 minus 5, right? If we rearrange this, we get x plus 1 is the same as 3 to the power of 5 over 2. I believe I worked this out to be about 14.6. So x is approximately 14.6, I think, 14.58, 14.6. Okay, so we know the graph is going to cross the x-axis somewhere on this side, where the value of x is positive 14.6. Where does the graph cross the... So this is the x-intercept. X-intercept. Where does the graph cross the y-axis? The graph crosses the y-axis when x is 0, and so where x is 0, right? So if we put 0 there, this log to base 3 of 1 is 0, so this term disappears, and we have -5, which means the graph will cross the y-axis at a point where y is -5. So substituting those in, so -5 there, that's where the graph crosses the y-axis. Remember, at the y-intercept, x is 0. If we put 0 here, then we are talking of log, twice log to base 3 of 1. Log of 1 for any base is always 0, so 0 times 2 is disappeared, so we are left with f of 0 is -5, and that's why the graph crosses at -5, and the graph crosses the x-axis at 14.6 as we've found here. And so when we sketch this graph, we get something looking like that. All right, from here we should be able to tell that the range is the whole, all real numbers form the range of this function. All right, the graph extends to infinity above and below the y-axis. Okay, so that is the range there. Okay, now part B of the question is to describe fully the transformation that maps our graph, maps the primary logarithmic graph onto our function there, f of x. You can only answer these questions if you've gone through a transformation of functions, assuming that you've done that. So we want this to be transformed onto that. Well, assuming that you've done transformation, then if we have a function f of x, the function is in blue, so you can see, you can trace it all the way onto the other side. So f of x, the blue part is the function, so it appears here f and those brackets there, all right? The input is in orange, so x becomes b into x minus c, all right? The transformation for x is therefore b and c in the x direction, and the transformation in the y direction, that means the transformation on the blue function there, is the a and the d in white. Okay, so if that's the case, let's do this for our graph or our function, which is logarithmic function. So equating to that, we have log to base 3 of x, so the blue letters indicate the function. So log to base 3 of x becomes twice log to base 3 of x plus 1, everything minus 1. So from here we can see that the x transformation, x becomes x plus 1, okay? Which means there is no b there. We can say b is 1. There's no change in b. So horizontally we can say that x transforms or maps onto x plus 1, so which is to say one step in the negative x direction. This tells us that the graph has shifted in the negative direction an amount of 1, okay? So b is 0, which means there is no horizontal stretching or compressing. What about vertically? We can see that the function f becomes twice, so the function is the blue bit, so the original function becomes twice the function minus 5. All right, this is telling me that in the vertical direction, the graph is stretched. It's stretched vertically. In the IB, we say dilation, so there is a dilation of scale factor 2 in the y direction. And minus 5 tells me that there is a translation of negative 5. That means a movement, a shift of negative 5 in the y direction. Okay, we can write that down. So 5 steps in the negative direction, that is the translation, and a vertical dilation, that means a stretch in the y direction of scale factor 2, and that becomes our answer. So hence the transformation that maps log of x into twice log of x plus 1 minus 5 has to be a translation of vector minus 1 minus 5 minus 1, because there is negative 1 step. This, if we put this here, means it's negative 1 in order to make this plus 1. Okay, so negative 1 step in the x direction and 5 steps in the negative y direction is a translation, followed by a vertical dilation, you can say stretch of scale factor 2. Okay, so that's how you answer that question. If you haven't done this, if you haven't gone into transformation, don't worry about it until we get there. All right, let's move to the next question. Find the domain of, so this is the second question that I asked you to do. Find the domain of the function f of x is log to base 4 of x plus 2. Once again, we know that for logarithmic function, to find the domain or the implied domain, we must remember that the argument has to be greater than 0. So we are saying here that x plus 3 must be always greater than 0, which means x must be greater than negative 3, all right, which means we have a vertical asymptote at the point where x is negative 3. We can already sketch this, but maybe we want to look for the y-intercept and x-intercept, so we can say that at y-intercept, x is 0. Right, so if we want the y-intercept, we make x 0. We can see that f of 0 is log to base 4 of 3. So log to base 4 of 3, because we've made that 0. So the graph will cross at log to base 4 of 3. We don't need to find the exact value. We can using a calculator. What about the x-intercept? Again, at x-intercept, these are important points to note. At the x-intercept, y is 0. At the y-intercept, x is 0. At the x-intercept, y is 0. So we come and make y 0 there. Therefore, 0 must be equal to log to base 4 of x plus 3. Okay, change to index notation. This is 4 power 0 is x plus 3. 4 power 0 is 1, is x plus 3. That means x must be negative 2. We know that at the x-intercept, in other words, the graph crosses the x-axis at the point where x is negative 2. And with that information, we can now try to sketch that function. All right. Usually you don't have to sketch it, but just as part of practice, let's see how to sketch this. So we draw the y-axis and the x-axis. We indicate the intercept. Okay, so the x-intercept is, first of all, the vertical asymptote at x is negative 3 there. And then we have a y-intercept at, I think, log to base 4 of 3. You can use your calculator to find that number in decimal. That would be, let's see, log of 4. You can find it, but it's approximately 0.4771 divided by 0.6021. So if we take this to be 5, approximately 0.5, and that should be about 0.48, and 6 is approximately 8. So this value here should be about 0.8. Use your calculator to find it. And with that information, we can sketch the graph. Doesn't really matter. So what do we have here? Okay, and our graph will now go up like that. Okay, so this, and of course, given this information, we know what the range is. So the domain, if we are looking for the domain in set builder notation, the domain has to be x is real and greater than negative 3, and y, the range is y is the whole number line, that all real values will apply. Okay, so that's that. Let's go to the next question. All right, so in this case, again, we want to remember that the argument has to be a number that is greater than 0. Okay, so according to that, the argument, the whole thing has to be greater than 0. So we are saying that 3 over x squared plus 3x, this has to be greater than 0. But if it has to be greater than 0, then it means the denominator also has to be greater than 0. So x squared plus 3x also needs to be greater than 0 for this to be greater than 0. We can factorize this, and we have x into x plus 3 is greater than 0. This means that x is greater than 0 and x plus 3 is greater than 0, meaning that x is greater than negative 3. So which of these two covers both? And I would say that we will take this to represent both the numbers, okay? But for this product to be greater than 0, it's also possible for x to be negative and x plus 3 also to be negative. So the second scenario is that x is less than 0, which means it's negative, and x plus 3 is also less than 0. In this case, x would be less than negative 3, and less than 0 and less than negative 3, which one would we take? And here we would have to take this one to represent both. Therefore, our graph must be such that x is greater than 0 and x is less than negative 3 there. Okay, so that's going to form our domain. X has to be, so x is real, greater than 0, but less than negative 3. That becomes our domain. Okay, we can look for the point where the graph crosses the y-axis. Does the graph cross the y-axis? Well, the graph crosses the y-axis when x is 0. If I put x is 0 there, I get 3 over 0, which is not possible. And this is to suggest that my line cannot cross the x-axis. Okay, so let's just go ahead and see what happens here if we sketch the graph. Okay, x-axis and y-axis. we know that there is an asymptote at x is negative 3, which is this one here. There is a vertical asymptote there, negative 3. We should also have an asymptote at 0. X is 0, which means the y-axis is an asymptote by itself. Okay, the y-axis is an asymptote. Okay, 0. The graph crosses the x-axis. We can find where the graph crosses the x-axis by where the graph crosses the x-axis, the value of y is 0. So at x-intercept, y is 0. So we make that 0, and we have 10. This, if we don't have a base here, it means base 10. So 10 power 0 is 1, must be equal to 3 over x squared plus 3. So change from logarithmic to index notation. All right, if you cross multiply, we get x squared plus, this is x here, plus 3x equals 3. X squared plus 3x minus 3 is 0. And when you solve this quadratic equation, we get the values of x. I think I've done it before this, and this is one of the values. X is negative 3.79 and x is 0.79. When you solve this quadratic equation, those are the values that you get. If we sketch the function, let's just put the other value. I think 0.79 was the other one there. Okay, and so how do the graphs look? The graph must be greater than 0 and less than negative 3 on the other side. And that's what we get for this function. We can see that the range is any value in the real number set. Okay. Number 4, f of x is that, once again, x minus 3 has to be greater than, x minus 3 squared has to be greater than 0. Similarly, if you solve that, you should get x is greater than 3. Okay, we don't need to do much now. If you have the idea, you should find that x has to be greater than 3. So there is a vertical asymptote at x is 3. Okay. And we can find where the graph crosses the x-axis. At that point, y equals 0. So 4 power 0 is 1. So we are solving the equation x. We are solving the equation x minus 3 squared is 1. X minus 3 is the square root of 1. Okay. Find the square root of both sides. So the square root of 1, which is plus or minus 1, and so x becomes plus minus 1 plus 3. So x values are 4 or x is 2. Okay, is that even right? Well, we agree that x has to be greater than 3, so although 2 is a solution to the equation, we can cancel it and say x cannot be that value. So x has to be 4, right? What do we get? Yes, there we go. Okay, this value cannot be taken since we have determined that the values of x have to be greater than 3. So although this is a solution of the quadratic equation, it does not apply to the logarithmic function. And so if we draw a graph, it should look like that. Right. Question D. F of x is log, without a base there means it's base 10. So log to base 10 of 1 over x plus 3. Once again, the fraction, the argument has to be greater than 0, meaning the denominator has to be greater than 0. If the denominator is greater than 0, we are saying x plus 3 is greater than 0. So x has to be greater than negative 3. Okay, x has to be negative 3, above negative 3, like that. Yeah? Where does the graph cross the x-axis, if any? Where the graph crosses the x-axis, so we can say at x-intercept, y is 0. So we make that 0. Okay, 0 is log to base 10 of 1 over x plus 3. change to index notation, becomes 10 power 0 is 1 over x plus 3. 10 power 0 is 1, 1 over x plus 3. Cross multiply, and x plus 3 is 1, and therefore x has to be negative 2. So we know the graph crosses the x-axis at a point where x is negative 2. Does the graph cross the y-axis? If it does, then we can say the graph crosses the y-axis. So at the y-intercept, x has to be 0. So we substitute 0 there, and we end up with f of 0, the point where the graph crosses the y-axis. The value is log of a third, which is the same thing as negative log of 3. Log to base 10 of 3. Log to base 10 of 3 is negative 0.4771, approximately 0.5, negative 0.5. That becomes our, but I think I've left it like this because it's not really important to find the value of the log, just to know the general idea of where it is. And therefore, when we sketch this graph, y-axis, x-axis, and the values that we just calculated, x is greater than negative 3, I believe, we found. Okay, that's negative 3 there. There was an x-intercept and a y-intercept. This was negative log 3, log to base 10 of 3. Okay, 0.4771, that one. And the x-intercept was, I think, negative 2, we found. And so, yes, and so if we draw the graph, it falls off like that. Once again, the range is all real numbers. The domain is x is real, but greater than negative 3. Okay, so that's the domain and range for this function. Here is another one, ln for log to base e. Okay, so once again, x squared minus, so to find the domain, we must reason x squared, so x squared minus x minus 2 has to be greater than 0. When we solve this, x, we can use the quadratic formula if you can factorize. Quadratic formula is 1 plus minus root of 1 plus 8 is 9 over 2. So x takes values of 1 plus 3 is 4 over 2 is 2. And the other one is x minus 3 over 2 is negative 1. So we are saying that the values of, the possible values of x, or rather, the vertical asymptotes, the values that will make this be equal to 0, which we do not want, must be at x is 2 and x is negative 1, right? So for x to be greater than that, so for x not to be 0, or for x to be 0, we must have this scenario here. So we do not want x is 2 and x is negative 1. So those will form our vertical asymptotes, but we still need to know where the graph is, all right? Where does the graph cross? Does the graph cross the y-axis? The graph crosses the y-axis when x is 0. So let me just, let's show this. At y-intercept, x has to be 0. But if we put x is 0 here, we get ln of a negative number, which is not possible, okay? Therefore, graph does not cross y-axis. So we reason like that. If we put 0 into the function there, we get ln log to base e of a negative number, negative 2. We cannot find the log of a negative number, as we've already said so. From here, the argument always has to be positive, and that means there is no point where the graph is going to cross the y-axis. What about the x-intercept? So again, at the x-intercept, we reason that y has to be 0. So substitute 0 on that side for y. So 0 is ln of x squared minus x minus 2. And so x squared minus x minus 2 must be equal to 1. E to the power of 0 is 1. And now we are solving this question. I believe I found the solutions. This is a quadratic equation. can use this space, x squared minus x, this comes this way and becomes minus 3 is 0. Solve this, we get x equals 1 plus minus root of 1, 1 minus 4, that is 13, divide by 2. So the two solutions are x is 1 minus root 13 over 2, and the other one is x is 1 plus root of 13 divided by 2. So the graph crosses the x-axis at those 2 points. The first one is negative 1.3 and the second one is 2.3. So this one gives negative 1.3 and this one gives x is 2.3. So we know that the graph will be crossing the x-axis at those points. So let's just graph the function, keep those values in mind. All right, and we can try and graph it. Let me keep them there and see if we can graph while they're still there. So there's the y-axis, there's the x-axis. We have a vertical asymptote at negative 1, should be, okay, and another one at positive 2, okay, and the graph crosses the x-axis at negative 1.3, which should be on this side somewhere there, and at 2.3, which is somewhere here. So if we put those values, negative 1.3 and 2.3, then the graphs can now be sketched. All right, that's the graph through 2.3, and the other one towards negative 1.3. Okay? Okay, let's look at the last one. Here is the last, I believe, the last problem. Once again, the argument, that stuff inside the bracket, has to be positive. And there are two conditions for this to be positive. So if this is going to be positive, both the numerator and the denominator must be positive, or both must be negative, right? So if both numerator and denominator are positive, then we are saying there that x minus 2 has to be greater than 0, which means x has to be greater than 2, and x plus 5 has to be greater than 0, meaning positive, meaning x has to be greater than negative 5. So which one represents both here? Greater than negative 5 and greater than 2, this will represent both. A number that is greater than 2 is also greater than negative 5. But a number that is greater than negative 5 is not necessarily greater than 2. Okay? So for the positive case, where both numbers are positive, we will pick x is greater than 2. Okay, similarly, if the two numbers are both negative, a negative divided by negative is positive. We want the argument to be positive. So x minus 2 must be less than 0, and x plus 5 must be less than 0. That means both are negative. In this case, this is x is less than 2, and here x is less than negative 5. So which one represents both? A number which is less than 2 is not necessarily less than negative 5, but one that is less than negative 5 is also less than 2. So we pick those two. So our domain, therefore, is x, are all real numbers, but x must be less than negative 5, while at the same time, x has to be greater than 2, and that's our domain. Let's see if we can sketch this, right? What's the x-intercept? Or the y-intercept? There is no y-intercept, because if x is 0 here, the argument becomes negative 2 over 5. We cannot find the log of a negative number. So this graph is definitely not going to cross the y-axis. Okay? Where does it cross the x-axis? It crosses the x-axis where y is 0. So we can make y 0. We can say log to whatever base, that's base 10, of x minus 2 over x plus 5 must be 0. Well, that means x minus 2, x plus 5 must be 10 power 0, which is 1. Cross multiply, x minus 2 is x plus 5. We are ending up with, what's that? We are ending up with x minus 2 is equal to x plus 5, which is also not possible. And so our graph does not cross the x-axis and it doesn't cross the y-axis, meaning the x-axis itself is an asymptote. So if we try to draw this graph, okay, x and y, we found that the graph, the function had to be, the domain was such that it was x is less than -5. That's what we calculated first. And it has also to be greater than 2. I believe that's what it was. So the graph is on this side and on that side. But the graph does not cross the x-axis either. It doesn't cross the y-axis and it also doesn't cross the x-axis. So we can use what we refer to as the Sine diagram to determine where the graph is, but this is not really important at this juncture. We get the Sine diagram by substituting some values of x. So we could substitute a value of x of 3 there. If we put 3 there, we get 1 over 8. So log of 1 over 8 is going to be a positive number. It's going to be a negative number. Log of 1 over 8 is a negative number, which will be below. So that tells me that the graph is on the lower side. On this side, if I put, say, -6 in here, I get -8 over -1. So that's log of +6, which is going to be on the upper side. So I know on this side the graph is above and on this side is below. Those are called Sine diagrams, which can wait for now. We don't have to go into them. Use your calculator to see how this graph looks like, and it should look like that. Okay? All right. This brings us to the end of this lecture. I hope you understood what's going on there. Please keep practicing with implied domains for the different types of functions that we've discussed. Thank you very much, and I'll see you for the next lesson.